Good morning, dear student. In today's lecture, we are very much interested in the important points regarding to our syllabus, that is diffusion in solid. So, what is diffusion and what are the different types or the mechanism of diffusion? So, all these points are covered in this lecture. So, let's discuss some important points regarding to the this diffusion process in solid. So, the first point is that. So, what is this diffusion? A flow process, a flow process that governs, a flow process that governs the movement, the movement of atoms, the movement of atoms and molecules, atoms and molecules in solid called diffusion. So, what is this diffusion? It is nothing but a flow process. It is just nothing but a flow process, that is which governs the movement of atoms and molecules in solid called diffusion. In other words, we can say that diffusion is occur as a result of a repeated jump of atoms from their sites to the other neighboring sites. Okay, so diffusion occur as a result of repeated jumps of atoms from their site to the adjacent sites. So this is the first one, that is the flow process that governs the movement of atoms and molecules in solid is called diffusion. The second important point regarding to this process is that the atoms and molecules changes their position. Atoms, so in solid we consider only atoms. So atoms changes their position, changes their position atom changes their position under the influence of, under the influence of under the influence of thermal energy, under the influence of thermal energy, stress gradient, thermal energy, stress gradient, then electric and magnetic field gradient, electric and magnetic field gradient, magnetic field gradient, and and the concentration gradient, and the concentration gradient. So whatever the atoms present in the solid, so atoms changes their position under the influence of thermal energy, stress gradient, electrical gradient, magnetic gradient, and the concentration gradient. The process of diffusion can be easily visualized in liquid, but it is very much difficult to observe in the solid. So whatever the process of diffusion we can easily visualize in liquid, but it is very difficult to observe in the solids. The next point is that when concentration of atoms of one element is higher at one point. Okay, the next point is that what is diffusion? Diffusion is nothing but the flow. Okay, so in this case, that is diffusion in solids, a flow process or a flow of atoms from one place to another place. So the next point is when concentration of atoms, concentration of atoms one element of one element is higher at one point, is higher at one point then than at another. So at one point there is a higher concentration of atoms of one element, and as compared to the other point. So when the concentration of atoms of one element is higher at one point then at another, or than at another, for example in alloy, okay, so the concentration of atoms of one element is higher at one point and other point it is very low, then what happen, that is the atom will diffuses. So in that case the atom will diffuse, the atom will diffuse from the region of higher concentration to that of lower concentration, to that lower concentration. So this is the process of diffusion, that is atoms changes their position under the influence of different gradients, and the concentration of atoms in one element is higher at one point than at another point, then the atoms will diffuses from the region of higher concentration to the region of lower concentration. The path of individual atom is random, zigzag and unpredictable. So whenever we consider the next point, that is whenever we consider the flow of atoms, that is for individual atoms, then the path of an individual atom is random, zigzag and unpredictable. So we can't predict the flow in the flow that is the flow is occur in which directions, that is the path of an individual atom, for single atom, path of an individual atom is random, it is not continue, it is random, zigzag and unpredictable. So we cannot predict, unpredictable. But when large number of atoms make such movements, but when large number of atoms make such a movements or get diffuse, then they produce systematic flow, So these are the some important points regarding to the diffusions, that is a flow process that governs the movement of atoms and molecules in solid is called diffusion. The atoms and molecules changes their position under the influence of different gradient. The process of diffusion can be easily visualized in liquid, but it is very difficult to visualize in solid. So when the concentration of atoms of one element is higher at one point than at another point, then the atom will diffuses from the region of higher concentration to the region of lower concentration. The path of individual atom is random, zigzag and it is unpredictable as compared to the large number of atoms when move, that when large number of atoms make such a movements, that is get diffused, then whatever they can produce is a systematic flow. So we can find out its direction, on which direction they move. Okay, so for large number of atoms we can easily find out the flow direction for these atoms. So let's discuss the important points regarding to this diffusion. It is the types of diffusion. The diffusion, it is classified into two types, that is first microscopic diffusion, and second, that is your macroscopic diffusion. So this microscopic diffusion, it involves the movement of individual atoms and molecules. Okay, so this microscopic diffusion, it involves the movement of individual atoms individual atoms and molecules. It involves the movement of individual atoms and molecules and its study in its study or in its study. Okay, so it involves movement of individual atoms and molecules and its study. And in this case, that is in microscopic diffusion, the diffusion is random. So diffusion is random, it is not continue. So diffusion is random. So at least you should remember this 2 point. That is for microscopic diffusion, it involves the movement of individual atoms and the diffusion is random. So if you consider the second type, that is macroscopic, it is not microscopic, macroscopic diffusion, it having different types. So this it is not micro, it is macro, it is macroscopic diffusion. So it having different types. Macroscopic diffusion, it having different types. That is, first one is self diffusion. That is, so what is this self diffusion? This diffusion is occur in pure metal. That is, atom jumps in pure metals. Atoms jumps or change their position in pure metal. It is called self diffusion. Second, that is interdiffusion. So whatever the diffusion in pure metal, it is called self diffusion. Interdiffusion means it involve in binary metal. For example, alloy, that is, it involve in alloy system such as copper and zinc, copper and nickel. So this is called interdiffusion. So it involves binary metals. Self diffusion, it, that is the movements or the atom jumps in pure metal. So in this case, the diffusion in two different, the diffusion it involve in binary metal. That is, for example, the alloy system. The next one is your third type. It is your surface diffusion. Surface diffusion is there. That is, atomic movement takes place along the surface. So atomic movement takes place along the surface. The next one is volume diffusion is there. Volume diffusion, that is, the atomic movements occurs throughout the volume of the solids. So diffusion occur throughout the volume of solid. Then there is another type, that is lattice diffusion. So these are all the types of macroscopic diffusion: self diffusion, interdiffusion, surface diffusion, volume diffusion. Then there is a lattice diffusion is also there. It is lattice diffusion. Is there. What is this lattice diffusion? This is the point imperfection induced diffusion in crystal. So this is your point imperfection point imperfection induced diffusion in crystal. Structure. Diffusion in crystalline material or crystal. And then the next one is pipe diffusion is there. This diffusion takes place along the dislocation edge. So diffusion takes place along dislocation edge. So these are the classification of the diffusion, that is microscopic and macroscopic. Self, interdiffusion, then surface, volume, lattice, and pipe diffusion. So in the next lecture we discuss about the mechanism of atomic diffusion. Thank you.